Okay, hi. Let's continue on with Unit 4. There's actually 5 lectures in Unit 4, and this is the third one. There's just a lot of background that you need to be able to do the problems in the next section. Okay, so what we're going to talk about is counting because it's going to be very important for you to be able to count all of the possible things that could happen, excuse me, given a probability situation. So let's just start off with a simple example here. Consider you're at a luncheon and there are 3 appetizers and 5 entrees you can choose from. You get to choose 1 appetizer and 1 entree, and you want to know how many different combinations could you make. So one way to organize those thoughts and make it easier to kind of count is to use a tree diagram. And so here I'm going to make a tree diagram. And you see I have soup, salad, and breadsticks. Those are our 3 appetizers here. Soup, salad, and breadsticks. And I've wrote them here. And now what we need to do is for each appetizer, we could have a burger, a pizza, a sandwich, a quiche, or a fajita. I'm going to use a B, a P, an S, a Q, and an F here. Okay. And so underneath each of these, we're going to have 5 options. And that's the same for this. And finally for this. Okay, and now to know how many total we have, we would just count all of these guys. Here, so 5, 10, and 15. So there's 15 total options. Now, this drawing a tree diagram works, especially until like you get it to stick in your head, but it's not very reasonable. What if it was 15 different entrees and 12 different appetizers? I mean, you could imagine that that would get pretty tedious to draw it all up. Well, fortunately, there's a rule for you. It's called the basic counting rule. And the basic counting rule says if you're asked to choose one item from different categories, the number of options you'll have is multiplying the number of items in each category together. So if we look back up here, or actually we don't have to look up here, let's look at the scenario that we just did. Now, keep in mind that this is basically without replacement, meaning that it's an unlimited number of soup we can choose from, an unlimited number of salad, and an unlimited number of breadsticks. And I also want to remind you that this particular section, this section of the unit, we're not really doing probability. We are literally just counting how many total options we might have in something. And then in our next lecture, we'll put the idea of probability and counting together so that we can work on bigger problems than we've worked on thus far. All right. So let's get back to this problem. How many options are there for appetizers? 1, 2, 3 options here. And there are 1, 2, 3, 4, 5 options here. So the number of total options I can't spell opens, sorry, options is equal to 3 times 5 is 15. So there's 15 total options. which is the exact same thing that we found there. So let's take a look at this problem, right? There are 21 novels and 18 volumes of poetry in a reading list for a college literature course, and you're supposed to select one novel and one volume of poetry to read during the semester. So how many total options would that be? Like, how many different ways could you do that? So total ways would be 21 times 18. So that becomes 378 total combinations of books for the class or something like that. You want to write me some kind of sentence so that I know that you know what you were talking about. Okay. All right. Why did this come up? Hold on. Let me get rid of it. Okay, thank you. Okay, so let me give you a little you-do here. Give you just a minute here. Be sure to read the question, right? So now we're at a luncheon and we get to have dessert. Yay! I love dessert. So, let you work this problem. I'll give a couple of about 30 seconds. So we're looking for the total number of meal options. Okay, if you haven't finished, go ahead and pause right now, but it looks like we have 3 appetizers, the 5 entrees, and now we have 3 options for dessert. So we have 3 times 5 times 3 equals 45. So there are 45 different meal options. All right, now let's keep on going. Okay, so we're going to start talking about a little more sophisticated ways to count some things and specific events that occur. And we're going to look at 2 different things. The first thing is going to be called a permutation. And the second thing is going to be called a combination. So let's talk about the permutation first. Now, if you haven't noticed so far, one of the things that's important in this class, no matter what unit we're in, is that you read the questions very clearly, very carefully, because that is going to often give you a hint on which way you have to go with solving the particular problem. It helps you with your decision-making skills, okay? Quantitative reasoning, way to make decisions using numbers and actual facts. Okay. So permutations occur when choices are made without replacement where the order actually matters. Okay. Because some situations the order doesn't matter. Now, a lot of times when you hear me talking about the order matters, I might say something like it is ranked. Ranked that means that order matters if something is ranked. Like you'd rather win $100 than win $1, right? Well, order matters then if we're talking about prizes. But if everyone gets the same prize, everyone gets the same cupcake, for participating in the game, then order doesn't really matter. The people that win don't get one prize better than the person that came in second or the person that came in fifth. Okay, so this is what I mean by whether or not the order matters. Now, this notation looks really crazy. And first thing I want to also point out to you is this notation here. This is a capital P with an N in the exponent and an R in what's kind of considered an index position or a subscript. So this guy is a superscript and this guy's a subscript. Now I'm going to write it like this. And that's what your calculator is going to look like. But my software that I have to use to type this stuff in does not give me this option. Okay, so this is the option for there, but I'm not going to use this notation too much unless I just give you the formula somewhere. All right, now this is what this formula means. It means N is the total. No, let's see. Hold on. Let me make sure. I'm going to not use the word total at all on the N. So the N is the number in the subgroup and R is the total number in the group. So this I'm going to just leave as total number. Okay, so this is kind of like the idea of how many vowels do you have in the alphabet? So N would be the vowels and R would be all of the letters in the alphabet, okay? We say the permutations of size R that may be selected among N choices. So N and R without replacement where the order matters. And so there's this formula here, and I'll come back to it. Don't worry about it. Let's first figure out why in the world am I yelling at you with exclamation points in a formula, okay? You may or may not know what that operation is. You're generally aware of adding, subtracting, multiplying, and dividing, but there are a few other operations, and one of them is a function called the factorial. And the factorial means that whatever number raised to that exclamation point basically is that number times all the digits smaller than that number multiplied among it themselves. So let's see here. So 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you do that in your calculator, you get 50,040. And 12 factorial is 12 times 11 times 10 all the way down to times 2 times 1. Now, I meant to, and I don't know. Hold on, y'all just bear with me. I should have put a calculator up so I could show you how to do this on a calculator. Duh. So, give me just a second. I know yesterday when I recorded, I messed up, so I'm going to put this in normal view and grab my calculator. Y'all will just have to bear with me for a minute. I always struggle with this. I don't know why, but I always struggle with this. Okay, let's see if I can do this. You don't usually get to see these lovely behind the scenes stuff, but here it goes. The struggle's real. Okay, here we go. All right, let me pull my little video up here and stick it up here all the way. Okay, so you don't want to have to go 12 times 11 times 10. I mean, it's not the worst thing, but it could be pretty crappy. Well, good thing to know that there is actually key on your calculator to do factorial. And you're not really going to be doing much factorial, but it's kind of a cool key. So let me just teach you how to do it. So let's do this 12 factorial. Oh, I get nagged by computer crap. Okay, let's do this 12 factorial. So what you have to do is you have to put in your number first, 12, and then we're going to go over here to where it says math, over to probability, and then down here to the fourth option. You see that exclamation point? Hit enter again. And that's how much 12 factorial is. Aren't you glad I didn't have you do it by hand? All right, so 12 factorial is, looks like 479,001,600. Okay, so pause the video right now, right? And go ahead and get your calculator up on screen or get it out of your bag or off your desk or whatever. And I want you to see what 150 factorial is, okay? So I'm going to have you do this, but I'm going to tell you that I'm doing you a trick. I just want you to make sure that you know how to do it. So first, what you do is you enter in the number, right? And then you go math, you go over to prob, which is probability, and you go down 4 places to the exclamation point. Okay, so let me do it real quick. We've got one, how did that PowerPoint open? Y'all, I'm so sorry. Okay, we've got 150. So you've got to put in your digit first. So enter in the number. Then we go over here to math. We go over here to probability. And we're going to go down to the fourth one, to that exclamation point, and hit enter. And hit enter. And yeah, you didn't mess up. Look what it says. It says error overflow. Now, sometimes you get something that says a domain error, like if you messed up putting your numbers in the list, right? You might get an error and it says domain error. But here, this is an overflow. That means that 150 factorial is so big that the calculator can't even put it in exponential notation. So physically computing these things out, very, very difficult to do. All right, well, but luckily, we've got this program on our calculator that we'll be able to do it with. So let's take a look at the next question here. So the next example, example number 5, says, how many ways can the letters in the word math be rearranged to form a 4-letter code word? Now, we're going to do this particular one 2 ways because I want you to really understand what we're actually figuring out, okay? And then we can just use the formula from then on, but I want us to actually kind of reason it out a little bit. It certainly helps students usually when I do that. So let's look at how many ways can the letters in the word math be arranged to form a 4-letter code word. So it doesn't have to make a real word. A code word means that it's just a series of 4 letters, okay? So let's do this kind of visually. Okay? And let's just deal with the letter M. How many different ways, how many different options can go in this first space? In fact, let me not put an M there. Let me just call this space 1. Because remember, we're just making a 4-letter code word. So if I haven't chose any of the letters from math yet at all, how many options can go in that first place? 4 options can go in that first place. And then we've used one of them, whether it's the M, the A, the T, or the H, it doesn't really matter, but we've used one of them. Now, how many options are left? There's only 3 options left to place the second letter, right? Are you seeing what I'm showing you? The third letter only has two options, and the fourth letter only has one option. Now, let me write like this: the first, the second, the third, and the fourth, just in case you're like, where did these fractions come from? What the hell is going on here? No, let me clear that up, okay? And now the total number is that multiplied together. 4 times 3 is 12 times 2 is 24. But this is also 4 times 3 times 2 times 1 is equal to 4 factorial. And if you put that in your calculator, let's do it real quick. We're going to go over here. We're going to say 4, math, down, enter, 24. Heck yeah, it works, right? So this is an awesome, cool little shortcut. Okay. Now, let's put this in terms of the NPR. Okay. So this is the total. N is the total of choices that you have, and R is kind of like what you're going after to be chosen. So if we're going to put it in that term here, up here, I'm going to erase my smiley face because I didn't have enough room here. Let me erase my smiley face. This would become, we have a total of 4. N is equal to 4 because there's 4 letters. And R equals 4 because there's 4 spaces to fill. We could have asked the same question. How many ways can we rearrange the letters in the word math to have a 3-letter code word? And in that case, it would be 4P3. But in this case, it'll be 4P4. And that is also equal to 24. And let's see how that works. I'm going to go through it down here again, but you're going to see that these all equal the same thing here. Okay, so let's look at this example. How many ways can 5 different door prizes be distributed among 5 people? So this is a 5P5 position, and we could draw it out like we did up here: first door prize, second, third, fourth, fifth, and we could write it out like that and figure it out like that. Okay. But I'm trying to get you kind of used to this notation because when we have much bigger numbers, it doesn't work as easy like that. You can always do it that way. That's kind of brute force, but it can be tedious and more efficient if you know how to use the technology. Okay. So the permutation of 5, choose 5, basically is how we say this. Okay. Now, how do we do this? We're going to first enter the value for N, okay? And in this case, it's 5, and I'm going to do one that aren't all the same numbers, but right now we're going to do 5. And then we're going to say math, and we're going to go over to the probability. And now this time we're going to go down, I think it's just 2, but let's go here. We go math, over to probability. We're going to go down 1 spot. Sorry, I said 2, but we're going to go down 1 spot to that. See that NPR right there? Yes. Go down 1 to NPR. And then you're going to hit enter. Okay. So when we hit enter here, See that the one little 5 is on the left-hand side, and we got a P, and then this little place flashing for the second 5 to go. We're going to enter in that 5. So then we'll enter R, and then enter for solution. Okay, so I entered in the R, and then I am going to hit enter for the solution, and in this case, it is 120. All right, so up here I could say 24 ways to arrange math into 4-letter code word. I realized I didn't write my sentence, and don't forget to write your sentence. And then here I could say 120 ways to distribute 5 different door prizes. Okay. All right, so let's take a look at our next problem. A charity benefit is attended by 25 people, and 3 gift certificates are being distributed for door prizes. One certificate is for $100, one's for $25, and one is for $10. Hold on one second. Okay. If no person received more than one prize, how many ways can the prizes be distributed? All right, now there's 2 things that you need to consider here. Now, of course, we're working with this particular formula right now. And this means that order matters, right? The order matters. And how do we know order matters? Well, because you'd rather get $100 prize than a $25 prize or a $10 prize, right? That tells me that the order matters. When the order matters, we're going to use this particular formula, the NPR formula. Okay, now what is N and what is R? That you have to know as well. N is almost 99.9% of the time, because I don't want to say always, always, because someone will come up with a situation where it isn't, but 99.9% of the time, the big number, right? 25. We're choosing from 25 people. N is 25, the large number. Okay. R is how many are we choosing? How many are we choosing? And R is equal to 3. So 25 because total people, so total number to choose from. And 3 is because that is the number of prizes. Okay. So when we put that all together there, we're going to have 25P3. And let's get that answer here. So first things first, you have to put that first number in. You have to put that in number in. So I'm going to say 25, and then I'm going to hit math. I'm going to go over to the probability, and I'm going to go down 1 to the NPR. See right there, the NPR, hit enter. And then I'm going to need to put that R number in, which is 3, and I'll hit enter. And that is 13,800. Now, that should freak you out just a little bit, that there is 13,800 ways to distribute the 3 prizes. Crazy, huh? Probability's nuts, but that is the case. Okay, so let's have you try this. You do. Okay, you need to identify your N, identify your R, and right now we know this is the formula you're going to use. Now, when you get to your homework, when you get to the quiz, when you get to your exam, you're going to have to decide what situation you have. Does the order matter or doesn't the order matter? And when we get done with this example, I think we're going to get to when the order doesn't matter. So you go ahead and do this, and I'll try to shush my trap. Okay, if you haven't finished, please pause. But if you have, awesome. N is the total number of people in the race. So N is equal to 8. And how many medals do you usually have in the Olympics? I think everybody knows that we have the gold, the silver, and the bronze. So there are 3 medalists. All right, so we're going to wind up with 8p3. And that's going to give us, when we do the math, oh, here we go. 8 math over here. Enter 3. Enter 336. So we would say 336 ways to deliver the medals or something like that, right? Deliver, distribute, something like that. Okay. So before I get to the other kind, let's have today's phrase. So the silly phrase for this lecture, which I believe is lecture M, if I am not mistaken, is the following. Are you ready? Get your pen? Okay. Ducks are the original stand-up comedians. I'm going to repeat it one more time. Ducks are the original stand-up comedians. And I do love me some stand-up comedy. Okay, let's keep on going here. We're almost done. Sorry, I got an itch on my back. We're almost done. Now, everything we've done so far with these permutations, order mattered. They were ranked. We cared. We want to get $100 versus 10. We want to win gold versus bronze. They rank. The prizes matter. The choosing has a status to it or something like that. But what happens if the order doesn't matter? And when the order doesn't matter, we use this other formation that is in CR, which is found right below the NPR and right above the exclamation point and the probability functions under your math button. So that's how we find it. Okay. And these are without replacement. All right. Everything that we've done, with the exception of our very first things up here where we're just counting and adding, those were without replacement. But this, or those were with replacement, right? It didn't matter. There was an unlimited amount of soup, an unlimited amount of breadsticks, an unlimited amount of salad. Okay. So, um, so, uh, that was with replacement and the idea that you could never ask for something and it not be there. But now this is without replacement. Like things are going to dwindle down. Like you can take away cards and a deck while you're going through doing those conditional probabilities and stuff like that. So it's kind of like a mix in your head a little bit with that, and I'll mix it all together next time. Okay, so let's take a look at the combinations. Now, pretty much from this point forward, although I promise you that the next at least this one is going to be a combination, but it's important for you to be able to make the distinction. Okay, so the rest of the examples, we're going to ask ourselves a couple of questions. And the first question is this a with replacement or without replacement? Okay, meaning is it independent or non-independent? And does the order matter? If order matters, yes, then we use PMR. So let's see. Let me just write this here instead of just saying it. So if we're doing order matters, okay, then we have NPR. And order does not matter. NCR, okay? And they're going to give two different answers, so you've got to be careful that you use the right thing. And there's nothing that's going to alert you that you're using the wrong thing other than you just made the wrong decision. Okay. All right. So let's look at this example. This example says, I have 9 paintings and room to display 4 of them at a time on the wall. How many ways could I do this? So first, are the choices with replacement or without replacement? Okay, and if we were in the actual classroom, I would hope that you guys would answer me and tell me what your opinion was. Since we're not, I can tell you that these are without replacement, because if I hang painting number 1 on the wall in space 1, I cannot hang painting number wall on the wall again. Does that make sense? So some of these questions you're going to have to think a little bit deeper on to be able to answer that. It's not going to be blatantly said with replacement, without replacement. You're going to have to decide what that situation bears. In this place, it is without replacement. Okay. Now, the fact that it is without replacement is what lets you know it's either going to be this one or that. If it was with replacement, we would just be multiplying 9 times 4 or whatever. Okay, but this is without replacement. All right. Does the order matter? Does the order in which we put them on the wall matter? In other words, are they ranked? Is there one more special than the next? None of that information is given to you. So does the order matter? No. And I would say not ranked. You don't have to give me a reason why you think the order matters or doesn't matter, but I want to explain to you so you can look back later. If your brains are scrambled by now, you can look back later when you watch this again, hopefully, if your brains are scrambled, and get it a little bit clearer. Okay. Probability sucks to learn. I'm just the first one to tell you that. It really does. But I'm going to make it as easy as possible. Okay. So not ranked, without replacement. So order matters? No, order does not ranked. Order does not matter. Okay, so order does not matter. This is the formula that we're going to use. We're going to use NCR. Now let's find out what our N is and what our R is. We have 9 paintings. That is our N. And we want to display 4 at a time. 9 and 4. And then we're going to use this. We're going to say 9C4. And let's get our answer here. Let me quit out of here. So we've got 9 math over to probability down to NCR this time. Enter, same, enter your 4 and enter. And we get 126. So there are 126 total ways to hang the 4 paintings. Which I still find just incredible that there's that many ways, but there are. Okay. So let's take a look at this next question. Our next question says, how many ways can a 4-person committee, president, vice president, secretary, and treasurer, be selected from a 16-member board of directors of a nonprofit organization? Okay, so we're going to ask our 2 questions. Are these choices with replacement or without? Well, no one can hold both the secretary and the vice president position. So we're looking for 4 individual people. So this is definitely without replacement. Okay. And then does the order matter? Well, frankly, yes. Yeah, the order matters. Maybe you don't want to be the president, but you want to serve on the board. Maybe you want to be the president. So order does matter here. So yes, order matters. So when order matters, we can say that it's ranked. And we're going to use that NPR formula here. Okay, so N and R. How many ways can a 4-person committee be selected? So that means that this is R from a 16-member board. So N is 16, R is 4, and we're going to get 16 P4. And let's run that. 16. Oops, one too many. One too many. Story of my life here. 4. Enter. 43,680. So there's 43,680 ways to choose the 4-person committee. Now, if you want to call utter BS on this, then holler at me, drop by my office hours, drop me an email or something, and I will show you the actual math on why this actually works. But for now, this is what we're going to use, okay? All right, let's see here. Let's give you a you-do. I'm liking these you do's right now. Let's give you that you do. Now, I'm going to give you the nice little hint that all these, like I said, 99.9% of the time it's without replacement. So we're going to go ahead and get that decision off your off your back, but you do need to answer this. And I'll give you a couple minutes. Okay, as always, if you haven't finished, go ahead and pause so you can. All right, and let's first ask, does the order matter? Well, let's see here. A charity benefit is attended by 25 people. Oh, I'm just going to go ahead and call that in, at which three $50 gift cards are distributed. So that is R, and they're the same. Does it matter if you got the first $50 gift card or the last $50 gift card? It don't matter. Does the order matter? No. And when the order does not matter, we're going to use the NCR. Order does not matter. We not care. Okay, because this is kind of hard to keep straight. Let me just do a little side note up here. So order matter. NPR. Order not matter. Now y'all watch this on how I write this. Not care. NCR. Not care about the order. The other one, you don't have to make up a saying for the other one, but if you can see the NCR, the not care, I'm weird. Y'all just probably know that by now. If you can see that though, then it'll stick in your head and you're like, oh, that's the one that I use when I not care. I not care if the order, not care about the order. So I'm going to use the NCR. Okay. And now I'll come back here, finish this guy up. So N, we have 25, C3. Get 2,300. So we can say there are 2,300 ways to distribute the 3 prizes. Okay, awesome. All right, we have one last example to do. I believe this is it. Yep, and then I have something else to say. Okay, a group of 4 students will be chosen from a 35-member class to represent class on student council. How many ways can this be done? Now, this does not imply any ranking of those 4 classes that are going to be chosen. They're just going to be representatives. Doesn't say four students to represent a class as president or anything that would let you have an idea that it is ranked here. So order does not matter in this situation. Okay. So order does not matter. Does it order matter? No. Without replacement, that means we do not care. So we're using NCR, not Karen. Okay, so we're going to have 35C4. We'll put it in here. Nope, too far. $52,360. So there are 52,360 ways to choose the student reps. Okay, now I want to remind you that what we did today is really going to build on what we're going to do next in our next lecture. Okay, what we're going to do in our next lecture is we're going to combine the probability, the conditional probability, and the basic probability from the first two sections, put it together with some counting and do kind of like larger probability problems. But I want to remind you of a few things, okay? Permutations, the order does not matter. Combinations, the order does not matter. We not care. Right? NCR, not care. Order does not matter, not care. Good way to remember it. All right. You're not going to be using these kinds of definitions here. And the way it's going to look like on your calculator is that. And that. All right. Okay. And remember that everything we did today, with the exception of the first couple of examples, which we use basic counting, we use basic counting when it's with replacement, and we use permutations and combinations without replacement. So if it is with replacement, it's that simple multiplying your choices. But if it's without replacement, like drawing cards out of a deck, and every time you go in to draw a card, you have one less card to draw from, that's without replacement. Okay. Rolling dice, that's with replacement because you can't take a face off of one of the die. Right. So there's two quick examples that might help you. All right. Thanks. Two more sections. One big section that puts it all together, one little section that puts it together kind of in a fun, really short way. So y'all hang in there. Come see me at office hours if you need some help. And be sure to read your feedback and stuff and all your homework and things. Some of you keep on submitting your work wrong and now you're getting zeros and you don't realize it. So y'all be sure to check your feedback and stuff. Okay, have a great day. Bye.